Hi, Ernel Simpson. I'm the Executive Vice President of R&D and Technical Innovation for TerraCycle that is headquartered in Trenton, New Jersey. I'm very pleased to be the keynote speaker today on the topic of designing for sustainable manufacturing. I know this is a subject that lots of people would like to hear, and it is a good thing that we can all get together and learn together about this particular topic. Let me start by first uh, pulling up the next slide here. It's sustainability, and the question is, what is sustainability? There are many different definitions of sustainability, and I managed to pick this one because it has some very specific indicators in this definition. Let me read the definition. They meet sustainability, meeting the needs of the present without compromising the ability of future generations to meet their own needs. Uh, this is a definition I choose to use because it talks about present, it talks about the future, it talks about generate needs of generations. So I thought this would be a definition that would, bring some keen thoughts to everyone. On one of the areas that we want to talk today is about unstable design approaches and stable design approaches. Back in the old days, years and years ago, uh, most of the designs were considered, unstable. Number one, they were designed specifically for aesthetics. Not that I have anything against aesthetics, but that being the sole uh, design criteria or criterion would make it difficult for most items. The second thing was design for obsolescence. We hear of people who design items so it could fail over a certain period of time, and so someone would have to run out and buy a new one. And design for disposability. We are a disposable society, and a lot of people like disposability, but because of disposability, we're now in a quandary with the amount of material, especially plastic materials, that has been disposed in various places, including the ocean, and that is not a very good design criterion at all. Anyway, if we look at how I view the unstable system. Now, I guess by now I'm a R&D guy, so I'll bring in R&D every time I figure that it's needed in a certain situation. Now, I look at this as a unstable, system. You have design at the top here, and design will move information to manufacturing. Manufacturing will move information to materials. Materials could be development of materials, or it could be materials you procure through a particular company than your own. And the information will go from design to manufacturing to materials and then back to design. And so you have these three different parts of the system that is controlling the system, and the crucial part that would be able to at least add a lot of clarity to some of the things that poor designs or poor manufacturings would get uh, is R&D, and they're left out. So this is what I refer to as an unstable system in my thinking. Bear in mind, as I said, I work for a recycling company, and one of the things that we find is that when we take materials in and we try to tear them apart to see how they can be recycled, we get some clarity on how things are and why recycling is at such a low level globally. But let me just walk through these requirements for a sustainable design here. Uh, Design for repair, reuse, and recycle. Design for waste and hazards minimization. Design for product disassembly. Design for continuous improvement. Design for energy efficiency. Design for manufacturing. Design for optional materials use, and design for cost effectiveness. Now, those are generally the things that are put in a system, and that system is considered a sustainable system. What I've done here is to add in this sustainable system R&D, and so you have now a very circular system that has all the parts, I think, that is necessary to generate enough information and to generate enough direction as to develop a sustainable system. And most people, in the designing and manufacturing areas will say, they may be able to do things, without contacting R&D, but we have seen cases where that happens, and usually the results are not very good. So, from my side, I would suggest that looking at any sustainable system, you have all the parts that are necessary to move the system along so that in the future we can have enough resources to continue our standard of living. What is expected from a sustainable system? I'll go through this list just to make sure that one can listen and get some idea of what they can do in their own cases. Energy consumption reduction is one. Waste elimination and reduction. Product durability and improvement. Health hazard elimination. High quality of manufacturing. Recycling, reuse, and manufacturing enhancements, and development of renewable resources. These are things that I got from this design for suitable manufacturing paper that was written by these two scientists listed below here. And they, lay out a system that I think if we can adapt globally, we would be extremely good in getting to a sustainable system, and hence sustainable design and manufacturing. In the past, packages, multi-layer packages that were designed to really, protect food and other items were, extremely complicated. And you had, as many as 13 layers on some occasions. And, it was almost prohibitive to recycle those particular items. A word of caution, the fewer layers a package or any item that has the fewer number of different materials incorporated, the better it is to be recycled and in a lot of cases reuse. And this is something that we're striving to do. So when you look at a drawing like this that indicates all these layers, it was good in the days when it was being developed, but right now it is a totally unsustainable design. What we're looking to do is to change all of this to a design where we can use a very small number of layers. And I have a wishful configuration for packaging here I'd like to see. Using a monolayer construction with a thin coating of barrier material to make sure all the barrier properties are in place. The coating should be a higher melt temperature than the main layer, so it can be removed via melt screening. Now, this is kind of what people who run extruders and try to recycle materials with the thermal mechanical system would really love to see, because that means the amount of recycling done right now would improve considerably. Bear in mind, thermomechanical is right now the leading form of recycling that you have globally. There is chemical recycling, which is just coming into its own. One of the things about chemical recycling, the name covers about 4 different types of recycling that involves, chemistry and chemicals. The one that I really like to talk about, because it can be used for smaller companies, and it's one where, in the case of you having a monolayer with a coating, you could simply dissolve away the coating with a common hazardous solvents, and it can be removed or recovered by precipitating the dissolution that is made by these coating dissolving in the solvent. There you can get the coatings back while you already have the monolayer that has been extruded, and you can get the recovery of both the monolayer and the coatings to be used for future application. In the last couple of weeks, I saw where Bloomberg mentioned that by the year 2029, there will be a tremendous growth in the development of packaging for food. And I looked at a list here of the number of things that the food packagers or the people who design the food packages are trying to do. I'm not going to read through every one of these, techniques, but I would suggest you take some time and read through this, and to see exactly what your company or individuals can help to do in the area of food packaging, so that we can get this area of packaging to be extremely sustainable, and in the meantime developing techniques that can be used for future use. That is my presentation, and if there's anyone that have any questions, please reach out, and you can ask the questions anytime you like. Thanks for listening.